What is up, everybody? So for 2.8, we're taking it back to Algebra 1 and just reviewing slope of lines, equations of lines, how to graph them, how to find the equations, and all that good stuff. So without further ado, here we go. So let's first talk about what slope is. All right, so remember, slope is a ratio of change. Right, and so what that means is how much is it changing horizontally and how much is it changing vertically, or the ratio of the change along the y-axis to the change along the x-axis. And guys, anytime I use the word ratio, you should be thinking fraction, okay, because that's how ratios are written. They're written as fractions. So for slope, remember we use the letter m, that is the variable that represents slope. And it's the change in y over the change in x. So that is the normal way we introduce slope. The changes in the y values over the changes in the x values, which then becomes what we know as rise over run, right? The change vertically over the change horizontally, which then leads us to our equation of how to find slope. And we use those sub numbers, y sub 2 minus y sub 1, x sub 2 minus x sub 1. And that's how we separate the two coordinates we're trying to find the slope between in our x and y axis. Now, it doesn't matter which one you pick as your 1s and your 2s, just like when we were doing the distance formula and when we were doing the midpoint formula. It doesn't matter, okay? But whatever you do, just stay consistent. Like, I don't want to do y2 minus y1 over x1 minus x2. That's a surefire way to get the problem wrong if you do that, okay? So that's the only mistake I ever see people really make, that or they put the x's on the top and the y's over the bottom, on the bottom. So just remember, it's rise is y is vertical, y-axis runs vertical, run, that runs horizontally, so rise over run. So let's take a look at 3 different examples here. So remember, slope is the change in y over the change in x. So I have 3 sets of coordinates. So what I'm going to do is I'm going to find the slope between these points. So I'm going to say this is my 1s and this is my 2s. So it's y2 minus y1 over x2 minus x1. Negative 2 minus negative 5, that becomes negative 2 plus 5. So I get positive 3. 6 minus negative 3, 6 plus 3, I get 9. My slope here is 1/3. We always reduce the fractions, especially when we're talking about slope. All right? Let's look at our next problem. 1s, 2s. So I'd have y2 minus y1 over x2 minus x1. 3 minus 3 is 0. 4 minus negative 3 becomes plus, so I get a 7. Now, if the 0 is in the numerator like this, then my slope is 0. All right, so there's something called zero slope. That is if our line is horizontal. So if I was to graph and plot those 2 points and then connect them, I would get a horizontal line. So any horizontal line has a slope of 0. Let's do our next problem. 1s and 2s. Negative 3 minus 2 over 4 minus 4. Negative 3 minus 2 is negative 5. 4 minus 4 is 0. When we have the 0 in the denominator, however, then our slope is undefined. And that's actually going to be a vertical line. Okay, so when your slope is 0, that is a horizontal line. When your slope is undefined, that is a vertical line. Try to remember those key concepts. And then finally, just to review, if my slope is 1/3, we're going to cover this in the next slide, but remember I go up 1 into the right 3. So if my line looks like this, that is a positive slope. If my line is going down and to the right, or up and to the left, however you look at it, that is a negative slope. So you have your positive slope, negative slope, slope of 0, and undefined or no slope. Undefined or no slope kind of means the same thing. So let's review just graphing a line. Very basic stuff. So there's two types of scenarios really where we're going to graph a line. There's times when we're going to know the equation of the line, or there's going to be times where we know the characteristics of the line. Like we know the slope and a point it passes through, or maybe we know 2 points it passes through. So let's go ahead and graph the one on the left first. So I have the line y equals 2x plus 3. Well, if we remember, we have the equation y equals mx plus b. And we're going to talk about this on the next slide. Remember, b is your y-intercept, and the 2, that is our slope. So what I would do to graph this one is I'd go up 3, because that's where it's intersecting my y-axis. And my slope is 2, aka 2 over 1. Remember, any whole number can also be written as a fraction. So like 5 could be 5 over 1, 11 could be 11 over 1. So it's my change vertically over change horizontally. So I would go up 2 to the right 1, because my slope is 2 over 1, and because it's a positive slope. Or I could go down 2 and to the left 1. And then once I have 3 points, guys, usually 3 points is more than enough to be able to graph a line accurately for an assessment. Let's look at our next one. Our y-intercept is now negative 2. So I go down to negative 2. My slope is negative 1/3. So remember, that is now I'm going down and to the right. So I go down 1 to the right 3, or I could go up 1 to the left 3, and then I am all done. Okay? Now, if I was just graphing my line where it was 1, 2, and negative 3, 6, all I got to do is find those points, 1, positive 2, 3, negative 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, and just connect them. That's all you have to do. Okay? Now, if I know a point my line passes through and I know my slope, I just go to that point, 2, negative 2, and then from there I just use my slope, up 1 to the right 2, down 1 to the left 2, and again, just connect them. Okay? Now, before we move on, I want to briefly talk about what a line looks like that has no slope or a slope of 0. So let's say I have x equals 4 and y equals negative 3. So x equals 4. If I want to graph that, you first need to go to where on your graph is the x value of 4. And that would be located right here. 1, 2, 3, 4. So what this is saying is no matter what happens, x's value is always 4. So if you're trying to graph the line x equals 4, that is a vertical line, aka there is no slope. So anytime x is the only variable, that is always a vertical line. So like if it was x equals negative 2, my line would be where it crosses the x-axis at negative 2. People always mess this up because they associate vertical lines with the y-axis, and it's actually the opposite. If I want to graph the line y equals negative 3, I go to the point negative 3, where y is negative 3 on my graph, and then I go through that one. So that is why anytime you have a y by itself, that is a horizontal line. Okay? So good reminders for both of those. Try not to make that mistake. Okay? So using slope to write the equations of lines. So there's two ways you can write an equation of a line. It's when you have the slope and a point it passes through, or when you know 2 points the line passes through. So if you know the slope and you know the y-intercept, we call that slope-intercept form. Okay? Y equals mx plus b. And guys, I want to apologize. I think I said There's either, if you know, let me rewind this really quick. So if we know the slope and the y-intercept, we can easily use the y-intercept form to write the equation of our line, okay? Where the m is the slope and the b is the y-intercept. If we know the slope and a point it passes through, or if we know 2 points it passes through, we have to use what's called point-slope form. And in point-slope form, we have the constants in our equation. So what I mean by that is the m, the x, and the y are never going to change in this equation. We plug our values in, excuse me, not the m. The x and the y are never going to change. We plug our numerical values in for the m, the x1, and the y1. So the x1 and the y1 is the point the line passes through, and the m is the slope of our line. Sorry, didn't mean to confuse you guys. So let's look at an example. All right, so if I know that the slope of my line is -1/2, and I know that it passes the it crosses through the y-axis at 2, aka our y-intercept, that is the easiest problem we're ever going to see. We just write y equals 1/2 x plus 2. I plug in my m right here, and I plug in my b right here. Now what if we know our slope and a point it passes through? In this instance, we have to use the y minus y1. So here's how this works. Y minus my y value in my coordinate it passes through equals my slope times x minus x1, my x value that I'm passing through. So first thing you want to do is simplify in here. So don't even touch anything on the left yet. Don't distribute yet. So x minus -2 is x plus 2. Now I'm going to distribute that -3/4. Y minus 5 equals -3/4 x. -3/4 times 2 is -6/4. That's going to reduce to -3/2. Now I need to add 5 to both sides. And obviously this would be way easier if I didn't have a fraction after distributing my slope, but it is what it is. So y equals -3/4 x. And so -3/2 plus 5, -3/2 plus 5 times 2/2 is 10/2. That gives us 7/2. So guys, what I had to do is I had to turn 5 into a fraction with a denominator 2, so I multiplied 5/1 times 2/2 to get 10/2. That way I could add them together. Okay, so -3/2 plus 10/2, positive 7/2. Okay. What if I had a problem where I knew the points that it passed through, but I wasn't given the slope? So in this instance, we have to find the slope first, and then I can pick between each point. So I'd still have to do 7 minus 2 over 3 minus 1, y2 minus y1 over x2 minus x1. I get 5/2. Once I know my slope, I could either pick this point or this point. So my options would be y minus y1 equals m times x minus x1. I could simplify that out. Or I could do y minus y1 equals m times x minus x1. And both of those, believe it or not, will give you the exact same equation. It doesn't matter which one you did. All right? So 3 scenarios. Scenario 1, they give you the slope and the y-intercept. Scenario 2, they give you the slope and a point the line passes through. Scenario 3, they give you the points the line passes through, and that's the one that takes the most work. You have to find the slope first, then you get to pick which point you want to use for your point-slope form. Last thing of the day, just talking about parallel and perpendicular lines. So remember, parallel lines are lines that have the same slope, okay, meaning they will never intersect. Perpendicular lines are lines when they cross, they form a right angle. Their slopes are opposite reciprocals. So remember, a reciprocal is if the number's 2 over 5, the reciprocal is 5 over 2. But now since it's opposite as well, we change the sign. So 3 over 4, its opposite reciprocal would be negative 4 over 3. 2's opposite reciprocal would be negative 1/2. So let's say I have two lines, line AB and line CD. We're trying to find whether or not they are parallel, perpendicular, or neither. So if they're parallel, the slopes will be the same. If they're perpendicular, the slopes will be opposite reciprocals. If they're neither of those, then their slopes are just different. Okay, so what we have to do here is find the slope of each line. So AB, that would be y2 minus y1 over x2 minus x1. So I get negative 6 over negative 2 for a slope of 3. For my next one, for line CD, I would do 1 minus 2 over 6 minus 3. That gives me negative 1 over 3. Negative 1 over 3 and 3, those are opposite reciprocals, so AB is perpendicular to CD. Let's do one more. Okay, actually we're going to change it up. It says write an equation of a line that passes through 1, 4 and is perpendicular to the line y minus 2 equals 1/2 6x plus 4. Now that might look intimidating in the beginning, but it's really not. Okay, so first things first is I need to figure out what the slope of that line is. So here's what we do. I'm going to distribute that 1/2, y minus 2. 1/2 times 6 is 3x. 1/2 times 4 is 2. I'm going to add 2 to both sides. Y equals 3x plus 4. So the slope of this line is 3. So let's go back to where he says it's write an equation of a line that passes through 1, 4 and is perpendicular to this line. So if my line's perpendicular, that means my slope is going to be the opposite reciprocal of 3. So in this case, m equals negative 1/3. So I'm going to take that slope, I'm going to take this point, 1, 4, and I'm going to use my point slope form. Y minus y1 equals m times x minus x1. Y minus 4 equals negative 1/3 x plus 1/3. Add the 4 to both sides. Y equals negative 1/3 x. 1/3 plus 4, I need to turn the 4 into a denominator of 3, so 4 over 1 times 3 over 3 is 12 over 3. So 1/3 plus 12 over 3 is 13 over 3. Algebra 1, okay? Let me know if you have any questions. Sorry I didn't do another example regarding this, but it's pretty obvious when you find them, if they're the same, if they're opposite reciprocals, or if they're completely different, then it's just neither. All right, guys?